The last section of Chapter 4 that we're going to have. We are going to go over 4.8 and talk about how to place triangles in a coordinate plane and how to find missing coordinates. Most kids find this section pretty easy, so once we go through it, whatever we skip in the video, you guys will finish at the end and we'll talk about it. Okay, so the very first thing you're going to do is you're going to take triangles and we're going to be putting them in a coordinate plane. So I just want to introduce this term of coordinate proof, which is going to be on your vocab page. A coordinate proof is going to use points, distances, and slopes to prove geometric properties. We are not going to get very deep into a coordinate proof. We'll do some of them second semester, but I'm just going to show you how you would set up a triangle to write a coordinate proof about it. So it says the first step in writing a coordinate proof is to place a figure on the coordinate plane, and we're going to label the vertices, which is what we're going to focus on today. So you're going to use these things as guidelines when you put your triangle in a coordinate plane. Number one, take advantage of the origin. You want to use the origin as a vertex, or you want to center the figure around the origin because the origin is super easy to use as the ordered pair 0, 0. Then you also want to place at least one side of the polygon on an x-axis, so that you have a horizontal side. You don't want it to be diagonal because it's harder to find coordinates that way, so put one side on the x-axis. Try to keep the figure in the first quadrant if possible. That's going to keep your ordered pairs positives, and it's going to be easier to use. And then finally, use coordinates that make computations as simple as possible. So when you're lining up a triangle in a coordinate plane, you're going to try to follow these 4 rules. Okay, so here's an example of one that's already been put in a coordinate plane. So the instructions for this person were to position an isosceles triangle on the coordinate plane so that its sides were A units long and one side is on the positive x-axis. So look at what this person did. They took the triangle and they made one side A long, and the way that I know it's A long is look at that coordinate that's on T. It's A comma 0, which means they used the x-axis as one of the sides, which is what they were saying would be a good practice. And then they also wanted it to be isosceles, so when they drew it, they drew these 2 sides as the legs to make those congruent. And so these would match, and then the base doesn't necessarily match the legs. But the coordinates of these, if you look, this ordered pair is 0, 0. This one is over A up 0 because they wanted the side to be A long. Now, last class, we didn't get to do the construction that I wanted to, so you guys are just going to have to learn this from me teaching you this because we didn't have time for the construction. But go ahead and drop a height straight down. When you have an isosceles triangle, that height in the construction we were supposed to do, what it does is it bisects the bottom side. It cuts that bottom side in half and makes that a midpoint. So that only happens if the height is dropped from the vertex angle. So now I want you to look at S's coordinates. So if you look, it says A divided by 2 because instead of going all the way over A, they went over half the distance. So another way to write that would be half A. And then they went up an unknown distance, so they chose another letter, which was the B, the next letter in the alphabet. So when you guys see this A over 2, just realize that that is halfway over, and then they went up B. And so we're going to be putting coordinates into the pictures like this once the triangles get in the coordinate planes. So let me show you some more examples. All right, this one was already placed in the coordinate plane. This is an isosceles triangle, so I want you to go ahead and drop the height straight down. Now, what's going to happen is that height is going to also make a midpoint. It's going to be perpendicular and it's going to bisect the base. So if you look, this base right here, it says is 2p in length. So if you think about how far you went over p. So the first coordinate of this point up here, of point C, is going to be p, comma, and then it says they went up q because we don't know how long it went up, so they just picked a different variable in the alphabet. But the most important thing is to notice if the entire segment on the bottom is 2p, then you went over 1p and then went up a certain distance, which we don't know. Okay, so the p is the most important thing there. That's because it's isosceles. All right, let's look at example 2. So on this one, they took and they put their right triangle in a different location. They put one of the vertices at the origin, which is legal. So let's look at what we have here. So if you look along the x-axis, you're going to look at how long that segment is. So the coordinates you're going to look at are 0 and 2a. So that length of a segment, that whole segment is 2a. All right, well, it says these segments are equal. So if I want the ordered pair up here, I got to go over 2a, and then if this one's 2a, you know this one's 2a because they're the same. So t's ordered pair would be over 2a, comma, up 2a. So that would be t. So keep in mind, when you're on the same horizontal line, you have the same x coordinates. When you are on the same vertical line, you have the same y coordinates. So, did I say that? I might have said that backwards. Let me see. So the same, I said that backwards. When you're on the same horizontal line, you have the same y coordinates, and when you're on the same vertical line, you have the same x coordinates. I said it backwards, okay? Which I'll kind of show you in another one. I don't use that concept as much as I say, okay, well, they went over 2a, so this one's got to go over 2a and up 2a. I kind of do it that way, but you can think about the horizontal and verticals too. Okay, go to number 3. So this is another isosceles triangle. This right here is the height. So I'm going to put right angles. And then realize that that height of the isosceles triangle, it bisects the base. Okay, so let's look at the different coordinates. So let's look at G, and let's look at the x coordinate of G. So the x coordinate of G is 2G, comma 0, because you went over 2G and up 0. So for E's ordered pair, you'd have to go back 2G and up 0. So that would be the ordered pair of E. So instead of going right and then up 0, you went left, and so that's towards the negatives. Okay, for F, think about F's ordered pair. This right here is the origin. So I'm going to go straight up and down and go straight up, and I'm going to get 0b for the F coordinate. That's because I did not leave the origin. I just went straight up from it. Okay, so again, what I was saying is when you have a vertical line, the x coordinates match, and when you have a horizontal line, the y coordinates match. If you want to use that, you can. Okay, so let's practice a few of these. So number 4 says the figure below is an isosceles triangle. We're going to go ahead and tick the sides that are congruent. I'm just going to tell you that these are the sides. You can pretty much tell that's going to happen there. And then this is going to be a right angle there because it's up against the xy axis. So if it's an isosceles triangle, we're going to use these ordered pairs to help us get B. Okay, so there's the origin, there's A, and we need to find B. So if you look at the length of this segment right here, this segment is 5 long, which means this segment needs to be 5 long. So now you got to think about how you're going to write an ordered pair for this to show that that is 5 long. Well, you don't go left or right at all, but you go up 5. So B's coordinate, this would be B, would be 0, comma 5. Basically, you're going straight up 5. Okay, let's try number 5. We're just going to finish this page out. So this is an isosceles triangle. Let's go ahead and tick the legs. The legs are going to match. Let's drop a height straight down. And remember that height is going to bisect the base. All right, we're going to find B's coordinates by using the coordinates of the other ordered pairs. So we have the origin, which is still 0, 0. And then we have A, which is 3, 9. So I'm going to go ahead and mark this in the picture for you guys to see. This is 3 in length, and this is 9 high. So that means they went right 3, up 9. So to get to this point, this would also have to be another 3. So if you add those together to get coordinates for B, they went right 6, but then they didn't go up from the axis, so it's 6, comma 0. So B's coordinate would be 6, comma 0. Okay, 2 more. Number 6. Again, an isosceles triangle, so I'm going to put the right angle here. They just made this oriented differently. They used the origin in a different way for this triangle and flipped it around. So we're going to look at how long this side is. Okay, so when you guys look at this side, we're going to use this ordered pair to help us. So from 0, 0 to 0, 8, that means this side is 8 long. which means this side needs to be 8 long. So to get this ordered pair up here, we're going to go right 8, then up 8. So B's ordered pair would be 8, 8. Last one. Again, another isosceles triangle oriented like this one above it. So we're going to go ahead and drop the height straight down and realize that that height also bisects the base. That's actually a perpendicular bisector. Okay, we're going to use the ordered pairs here and here to help us get B's ordered pairs. All right, we realize that this whole distance is 10, so that means that height split it into 5 and 5. So we're going to find the ordered pair by realizing that we went right 5, up 7. So B's ordered pair would be 5, 7. They're kind of puzzles. They feel puzzle-ish because you're finding missing coordinates using the other coordinates. Okay, it's the beginning of what coordinate proofs would look like, which we'll talk about more second semester. Okay, you guys, after we get done with the video, you guys are going to try these 4 and check your answers with the key. All right, but we're going to skip down, and I'm going to do number 11, and then again, this one that's supposed to be number 12, you're going to do and check with the key. Okay, so the last example we're going to do is this example here. And you'll have some of these on your quiz. So number 11 is going to give you 3 coordinates, and it's going to give you some information here. So over here, I'm just going to sketch a picture of my triangle, and I'm going to label it A, B, C. They want us to know that they're going to give us information, but then they want us to classify the triangle as scalene, isosceles, or equilateral when we get done. So that's what our answer is going to be. And then it says, then determine if the triangle is a right triangle. Show work to explain your answer. All right, so the first thing let's do is let's try to classify it as scalene, isosceles, or equilateral. So let's take the information they gave us and let's put it into our picture. So BC is the square root of 74. AC is 2 square root of 37. Now, automatically, I know it's not going to be equilateral because they don't match yet. But if I get my third side and it matches one of these, it'll be isosceles. If I get my third side's length and it doesn't match, it's going to be scalene. So I already know it can't be equilateral. Okay, so the missing side we need to find is AB. So we're going to do the distance formula. So you've been practicing the distance formula, so hopefully it's better for you now. But we're going to find the distance from A to B. Okay, so I'm going to subtract the x's first. Negative 6 minus 1 squared plus 6 minus 1 squared. You can flip these around if you want. It doesn't matter as long as you're going x minus x and y minus y. Okay, so this becomes negative 7 squared plus 5 squared. Okay, so then we're going to get the square root of 49 plus 25. And that's going to give us the square root of 74. Oops, 74. Okay, now I'm going to take that and I'm going to come over to my picture and I'm going to put the square root of 74 in my picture. Now I can clearly see what type of triangle this is. These two sides are congruent to each other because their distances matched. So the definition of an isosceles triangle is at least 2 congruent sides. So we're going to say this is isosceles, I-S-O-S-C-E-L-E-S, and we're going to say there are 2 congruent sides in the triangle. All right, so half our question is answered. And again, we're using coordinates, which is why it's in this coordinate section. Okay, the second thing that we're going to do is we're going to decide if we have a right triangle or not. This is going to be new, so I'm going to draw a little line down here because in order to decide if it's a right triangle, we need to use the slopes. So that's why these slopes are over here. So I'm going to draw a triangle again up here, and I'm going to put those little slopes in. So this is A, B, C. The slope of AB was negative 5/7. The slope of AC was 1/6. And I still need to find the slope of BC. Okay, so I'm going to go ahead and find the slope of BC, and then we're going to talk about how we know if it's a right triangle or not. So the slope formula is where we subtract the y's. It's y2 minus y1 over x2 minus x1. So we're going to subtract the y's for BC. So I'm going to go 8 minus 1 on top. And then if I go 8 minus 1, on bottom I have to go 6 minus 1. So that's going to give me 7/5 for my slope. And I'm sorry, there's not much room there. So 7/5 is going to come over here, and I'm going to put it in my picture, 7/5. Now I'm going to look at the three slopes, and I'm going to notice something special about these two slopes that are right here. One of them is -5/7, and the other is 7/5. And those are opposite reciprocals. And when they're opposite reciprocals, that means they're perpendicular. And when they're perpendicular, by the definition of perpendicular, we have a right angle, which means we have a right triangle. So what you're looking for is opposite reciprocal slopes. If you have two slopes that are opposite reciprocal, then you have a right angle, and then it's a right triangle. So it says, is it a right triangle? And I'm going to say yes, exclamation point. It is. And the reason is because two slopes are opposite reciprocals. And that's going to cause that to be a right angle, which is going to cause it to be a right triangle.